Welcome everybody, this is Dávid Juhász, and today in this episode we are going to discuss the details of the chi-square test. The exact exercise can be read in my book. The main task here is to help Papa Smurf decide whether there is a connection between the heart attacks happening recently and the C-sections which were performed approximately 40 or 50 years ago. So here we want to determine whether there is a connection between the occurrence of the two events, so between heart attacks and between the previous C-sections. The first step, which of course is given to us, is the contingency table, so this table of observed frequencies. Observed frequencies means that Papa Smurf sits down and documents everything. And by documenting everything, I mean he writes down the number of Smurfs who had a heart attack and who didn't have a heart attack, and he also makes the groups of C-section and non-C-section Smurfs. And of course, he overlaps the two. So we can see 96 Smurfs here. Just let me zoom in a little bit. So we can see 96 Smurfs here who had a heart attack and were C-sectioned in the past, and 76 Smurfs who weren't C-sectioned, but they also had a heart attack. And if we take a look at the other column here, we have got 60 healthy, and I mean non-heart attacked Smurfs, so Smurfs who didn't suffer from a heart attack, and we have got 68 non-C-section Smurfs who, of course, didn't suffer from a heart attack. And of course, these 60 Smurfs were C-sectioned, but still they didn't get hit by the heart attack. And the first step is, which I have already done, but I'm going to do this again, is to calculate the terminal sums by typing in sum and summing up the actual row or column. So we have to sum up the corresponding row or the corresponding column. Here, if I click into the equation, the formula itself, it gets highlighted what I'm summing up. The same thing happens here when I sum up the so-called columns. Of course, I've got the total sum of Smurfs, so the total number of Smurfs given, this is 300 in this case. The next step is to make the so-called expected frequencies contingency table. Here I have already copied this table, which is going to be dedicated to the expected frequencies. But why exactly do we need expected frequencies? We need them because, as we can see, 300 people is a relatively low number, so it's just a sample. I want to compare it to a population, to an imaginary population, and that's why I need the expected frequencies, because these frequencies are going to reflect to me the would-be frequencies of an imaginary population. So the population which contains these 300 Smurfs. But how do I make it a population, even an imaginary one? We've got a formula for this, which is the terminal sum of the corresponding row times the terminal sum of the corresponding column divided by the total number of people, in this case Smurfs, so the dot count, to put it statistically. And here the formula is just the same. Of course, not like this, but this. Of course, if you mistype something like I did, just don't panic. Grab either the cell or just hit the backspace. No one's going to pay attention. Just don't panic and stay frosty. So got these. And of course I encourage everybody to just use the dollar signs. And now let's just think about what to put into a dollar sign or what not to put in a dollar sign. Here I need to preserve this, and by putting it in to dollar signs, what do? I lock that actual cell. It can be the whole cell, or it can be only be the row, only be the column. Here I need this cell locked. This cell also needs to be locked, and only this can move. So only the blue will be movable. That's why I'm just fixing all these. Of course, it doesn't change this result here, but if I drag it down, I should be getting this. Exactly. The same goes here. I'm just locking the purple and the red cell within dollar signs, and I'm dragging it down like this. Just a safety check. Yes, I've got everything. So these are the so-called expected frequencies. And if we take a look at the terminal sums, and of course the data count don't change, so these are the same, but these frequencies, the frequencies of the C-section, non-C-section, heart attack, non-heart attack Smurfs, they did change a little bit. So now, as the next step, we need to compare the two of them, and we need to get the p-value for the chi-square test. I'm going to give you the shortest way of doing this, the shortest and safest way of doing this, which is the chi-square test function. The actual range means the observed range, and the expected range means, of course, the group of expected frequencies that we have previously calculated. We don't need to do anything else, just put them in brackets and let's see what comes out as a result. I hit enter and the same thing happens. P-value is 0.13 if I round it up, but if I give it as a percentage, it's 13%. 13% p-value means that I accept the null hypothesis. So the null hypothesis is accepted, which means that there is no connection between the occurrence of heart attacks and C-sections. Okay. So we have got this exercise solved, and that's all you need to know to be able to do the chi-square test. Now I would like to share something extra with you, which is not obligatory. Sometimes they ask it, and it's better to know that the chi-square test consists of the chi-square values, which are calculated as observed minus expected on the power of 2 divided by the expected. And just let's put it inside brackets as well. Okay. Now just fix it and drag it down like this. Okay, I'm sorry, now you don't need to fix this. Okay. So that was all about chi-square tests. If you have any questions, feel free to DM me or write a post or just reach out to me any way you can. This was today's episode of Medical Statistics Made Easy. Stay tuned for more content. Have a nice day. Bye bye.